This video will cover how to calculate hypothesis tests for 3 or more means to see, are those means statistically the same, or is one or more of those means statistically different, like our airplane over here on the right. I'm going to use an example to show you how to do this in Minitab. A regional package delivery company is considering changing from full-size vans to minivans. The company sampled minivans from each of 3 manufacturers. They sampled the number the manufacturer was able to provide for the test. Each minivan was driven 5,000 miles, and the operating cost per mile was computed. The question that we have is the average operating cost per mile for these 3 types of minivans different from each other? We want to be able to see if one of them is cheaper or one of them is statistically more expensive. We've got some experimental data in a spreadsheet we're going to use to conduct this test. We want to see, do the experimental data provide evidence that the average operating costs per mile for the 3 types of minivans are different from each other? We're going to assume a 5% level of significance. What we're attempting to prove is that at least one average is different from the others. At least one average operating cost is not the same as the others. This is how we write an alternative hypothesis for an ANOVA test, a test for 3 or more means. There would be too many different combinations of equations to try to write, so we just need to see that at least one mean is different from the others. So we're going to start by assuming then that all means are equal to each other. The average operating cost for minivan 1 is assumed to equal that of minivan 2 and that of minivan 3. So we'll assume all 3 means are the same. To perform an ANOVA test is to perform an F test. The F distribution looks like the distribution on the right. It's actually a whole family of distributions that are dependent on the degrees of freedom associated with the thing we're attempting to test. You can use an F score compared to an F critical approach to this hypothesis testing, but we're going to focus on the p-value. If you choose to use the F score and the F critical, you're looking for a large F value out in the tail, where only 5% of the probability is out in that tail. Let's let Minitab do the work for us here. In Minitab, to compare 3 or more means, we go to Stat, ANOVA, and then we're looking at a one-way analysis. We're assuming there's only one difference between these 3 vans. Which manufacturer made the van? So we're going to just use this one-way option here. You could have more than one way that the data differ. We could have, for example, several tests that we're having students take, and we want to see if there's a difference by gender. That would be a 2-way test, not a one-way test. When we open the dialog box here, we get 2 options. The first option says response data are in one column for all factor levels. What that means is that the thing that we're trying to measure, our numbers, are all in one column, and the IDs are in a second column. So we may have the operating costs in the first column, and then which van it was in the second column. That's not the case for us. We have each factor in its own column, so response data are in a separate column for each factor level. That's the option we're going to choose here. So once we choose that option, we click into this response box and we double click in all of the variables we're interested in analyzing. We're also going to click in this box called comparisons. We click on this comparison box not for the hypothesis test, but for something we may use should we be allowed to reject the null hypothesis. So click on comparisons and check the box next to Tukey. I always joke that that's Turkey, but we're going to check the box next to Tukey. That's all we need to check for now. Hit OK again, and we'll get our output. Here is the output from Minitab. You'll see Minitab says all means are equal, not all means are equal. That's our null and alternative hypothesis. The 3 factor levels are minivan 1, minivan 2, and minivan 3. For those of you that like to use the score versus critical value approach, here is your F value. You would compare this to an F.inv.rt of 5%, And then you need 2 sets of degrees of freedom, so you would plug in the 2 and the 9 there, and you could make that comparison. I'm going to use the p-value approach because that's the most simple route. We're trying to prove that at least one mean is different from the others. In our F distribution, we've got this F score. That F score happens to be way out here, 7.91. There's only a 1% chance that we could get this value way out here if the means are the same. So the means are probably not the same. In fact, we can say, since the p-value is less than alpha, we can reject the null. We know at least one van's cost is statistically different from the others. The question is, though, which van is statistically different? So remember that we clicked into that comparisons box and checked something called Tukey. When you check that box called Tukey, you get this additional output, this Tukey pairwise comparison. What this test does is look at each of the means in a pairwise fashion to determine if those means are statistically the same or different from each other. And then this gives us these groupings. The groupings are what allow us to see which ones are the same and which ones are different. You'll see in this case, minivan 3 is in its own group. That means minivan 3 is statistically different from the other minivans. In fact, we can say, because this mean is higher than the others, that minivan 3 costs statistically more to operate. Minivans 1 and 2 are in the same group, so they're not statistically different from each other. So I would say minivan 3 costs statistically more to operate, and minivans 1 and 2 are the least expensive to operate. They're not statistically different from each other. It is possible to have some strange things appear underneath these groupings. For example, we could have minivan 3 be a member of group A, and maybe minivan 1 be a member of group A and group B, but minivan 2 only be a member of group B. That would mean minivan 3 and 1 are statistically the same. Minivan 1 and 2 would also be statistically the same, but minivans 2 and 3 would be statistically different from each other. So you can use this grouping to see which of the means are statistically different from the others. In our case, we can say minivan 3 is statistically more expensive to operate, and minivans 1 and 2 are statistically the same in terms of operating costs. If it were me and my company, I would choose to get minivans from company 1 or company 2, or some combination of companies 1 and 2. Thank you for watching, and I'll see you again soon.